With that, we move to the next talk, which is a memory vision talk from Dr. Nagasubramaniyan Chandrasekaran, who is Senior Vice President at Micron. We have a recorded video from Dr. Naga to play. So while our the DJ team puts up the video to share for you, I'll just quickly introduce Dr. Naga and then we'll play the video for you. So Naga is Senior Vice President of Technology Development at Micron. Dr. Chandrasekaran leads Micron's global technology development and engineering efforts related to the scaling of current memory techniques, advanced packaging technology, as well as the emerging memory technology solutions to support Micron's future requirements. He also manages the mass technology development, corporate characterization lab, and the advanced modeling and data analytics R&D fabrication operations at Micron's headquarters at Boise. Dr. Chandrasekhar has authored several keynote publications, patents, and he has served as an invited panel speaker at several conferences. He has received several awards, including Jury Thirsty Outstanding Young Manufacturing Engineer of the Year Award. Dr. Chandrasekaran earned a bachelor's degree in mechanical engineering from University of Madras. He earned both a master's and doctorate degree in mechanical engineering from Oklahoma State University and a dual executive MBA from the University of California, Los Angeles, and National University of Singapore. With that, it's a privilege to get his talk in front of you, and we will have Anand Ramamurthy from Micron to come up on stage at the end of the talk to answer any questions that you have. Can we play the video?
This opportunity to share my thoughts through this recorded presentation. Over the last 41 years of our history, Micron has developed into the third largest memory and storage company with over $20 billion in annual revenue. Our vision is to transform how the world uses information to enrich life for all, using our scale, global reach, and an innovative culture. We are making a difference in the world and in the process, transforming human life. Today, when we could all use more positive energy, I want to share the progress we have made as humankind using semiconductor technology. In the last 2 decades, we have seen an exponential increase in innovation happening around us. New products, solutions, and business approaches are changing the way we function as individuals and as a society. These changes around us are enabled by innovations in the semiconductor industry and in particular, memory and storage technology. Semiconductor memory is transforming our lives. Let me share some examples with you. One of the biggest area of change we are observing is in the field of medical science, where we are able to provide personalized treatment and delivering results at a faster pace. I want to share a story with you. In 2013, Shirley, an individual who was diagnosed with stage 3 ovarian cancer, was frustrated by the lack of information and answers regarding her diagnosis. She took it upon herself and started working with a professor from University of Southern California to develop a machine learning algorithm and find data patterns within her tumor. The system used high bandwidth memory solutions to store and move large amounts of medical data to processing units and streamline the data storage and analysis. This machine learning system eventually pointed Shirley towards an immunotherapy drug that helped cure her ovarian cancer within 2 months after beginning the experimental drug treatment. Shirley's doctors announced that her tumor had disappeared. This would not have been possible a decade ago. Today, we are generating a lot more data, a significant increase year over year. And all of this data is also enabling us to gain more intelligence using faster processors and advanced algorithms. Semiconductor memory solution is playing a key part in enabling these disruptive and advanced medical treatments. It's the ability to analyze data and gain intelligence that's enabling us to also provide precision medicine in the real world. We are able to take data and find patterns much faster. We can look at images of different cancer patients, and we are able to detect lesions on a skin and identify the difference between a skin cancer, a type of skin cancer, and just regular allergy in our skin. This is made possible by looking at patterns and quickly getting to identify and make a clear diagnosis. We are also having a lot of IoT devices that are now attached to our body on a regular daily basis. These devices are able to collect medical records as well as data from our body, and we are able to get insight from this data and revolutionize the patient outcomes. All this information that we are collecting from our day-to-day life and connecting the medical records and using advanced algorithms to identify issues faster and cater a treatment that's very specific to the individual so that we can find the cure at a faster rate. What we thought was science fiction 20 years ago is now becoming a reality. A doctor in London is operating on a patient in Singapore using high definition virtual reality equipment and working hand in hand with a robotic counterpart. Now, in an operation, a surgeon needs to react to stimuli in under 10 milliseconds. In robotic surgery, that has not been possible in the past. But now, 5G's low latency turns a failed operation into a success. And once again, semiconductor technology has enabled 5G, and it is providing unprecedented performance, responsiveness, and connectivity that's changing the technology around us and also transforming how we lead our life. It's not only these advanced medical fields and advanced science with astronomy and robotics and space shuttles, but we also see technology impacting our day-to-day life. We have secure, smart, and energy efficient homes today. There are so many devices within our house that are connected and improve our energy efficiency, thus contributing in a better way to the green planet. We can access richer content anytime, anywhere. In this COVID time, where we are able to have our schools and colleges operate online by sharing data, we get entertained watching movies at our home. We can continue to communicate between us, like this conference, or continue to do our job working from home. And all of this made possible by the richer content that we are able to access and share between continents. And there is an increased focus on health and wellness, like I indicated, and Micron's broad leading edge portfolio of high bandwidth, low power memory and storage are perfect for the consumer devices that we are able to use in many of these applications. Working from home can be stressful today, and we all need a way to de-stress. So memory has changed the way the gaming industry experience for most of the gamers. Gaming industry is exploding. Not only are the number of gamers increasing, but the software spend is projected to grow to 38% by 2021. And by using graphics memory, we are able to provide better experience for the gamers. And the video game play has gone from being a casual pastime to a worldwide phenomena in less than a decade. So professional gamers and gaming streamers influence is growing with millions of followers, and it is continuing to increase. And the memory solutions that we are able to develop in terms of high bandwidth, improving the data rate, but also providing a richer content experience is the way that we are able to make a change in this industry. Harnessing the power of data It's not only applicable to several of these industries that I highlighted, but it's also used to advance the semiconductor industry itself. We are able to use our own memory solutions and also the power of faster processors and advanced algorithms to improve the efficiency of our own semiconductor factories. We have end-to-end automation enabled within our factories. Today, when you walk into a semiconductor fab, it's nothing short of watching a sci-fi movie, and we'll be impressed by the fewer human touch points that exist within a factory. Most of the operations can be done remote and can be controlled from outside the clean room environment itself. We have deployed smart sensors at every part of our factory and manufacturing operations. We can have data science experts working on our equipments as well as our process solutions to make sure we can develop technologies faster. Engineers in India are able to develop solutions and make a difference to silicon that's running in a Taiwan factory floor. Automated defect detection, which is similar to the image analysis example that I quoted earlier in medical science, we are able to take defect images on wafers and classify them in an automated fashion. All these improvements that we are able to apply to our own semiconductor factories has improved our yield maturity, which is able to achieve higher yields much faster. We can improve our manufacturing output, and we are also able to improve the overall quality of the products we produce. All these innovations are enabled by continued technology scaling. When I talk about technology scaling, it's the silicon technology that's been scaling according to Moore's law for the last 40 plus years. And the technology scaling needs to meet advancements in power, performance, while reducing cost of the solutions that we are providing to our customers. We have to meet end customer requirements, but the application space and the end customers are also evolving rapidly. We have new industry terminologies with respect to data centers, cloud, autonomous vehicles, edge applications, Internet of Things, new mobile platforms. All these different end markets have unique demands, many of them stringent from quality and reliability perspective, while they also demand a lower power and higher performance and lower cost solutions. So the industry itself continues to face significant challenges with technology scaling while we are trying to enable new applications for our customers. Let's take a more systematic view at the challenges that the macro challenges that we are all facing in the data era. What is going up, as you can see within the graph on the left, the amount of data that we are generating is growing exponentially. Every 2 years, we create more data than in the whole of human history combined prior to that. That's a lot of data that we are generating in every 2 years. If I go back to 1979, when Micron produced its initial DRAM chips, they were 64 kilobyte DRAM. It was the world's smallest DRAM memory chip at that time. And today we are talking about 32 and 64 gigabyte DRAM solutions, which are 1,000,000 times more capacity. And this is going to continue to grow with the increase in data generation that's happening around us. And why is the data growing so fast? Because we have enabled more data to be generated by every individual. The content that's being generated by individuals in the world is increasing exponentially. And the nature of the data is also changing. We were used to static data, but today the data is coming at us very fast. And this data also has to be analyzed very fast. And that's going to be the challenge when we are looking at all our industry, whether it's in transportation or telecommunications or in entertainment or in banking. Every one of this industry is starting to look at more data and data as the new currency. but the currency can only be realized based on how much intelligence we can generate from the data. So what is going down? The time to get intelligence from the data is shrinking. It's shrinking regularly. We are looking at energy constraints in data centers and our mobile phones. And every one of these applications are demanding that the total power consumption be reduced. There's also a growing skill gap when we look at this increased scaling requirements from a silicon perspective, as well as needing continued advancements in AI and ML fields. There is a growing skills gap, and that needs to be filled in as well. So these are some of the macro challenges that we are facing as an industry. But when you look at how the memory and the semiconductor industry is solving some of these problems, macro challenges that we face with the data generation. To solve many of these challenges, we need to come up with advanced memory solutions. When you look at the image on the left side, I'm showing a traditional storage hierarchy where we start with a hard disk drive, and then it goes into solid state drives, eventually to a DRAM. At a high level, if you look at this memory hierarchy, DRAM is the fastest memory, and it has the fastest processing speed, but its cost is high. On the other hand, when you go down this pyramid from NAND solutions that are used in solid state drive or HDD, the hard disk drives, they are the lowest cost storage solutions, but they have the slowest speed. So you have this spectrum of performance and cost where one of the memory solution provides highest performance and high cost, and the others provide lower performance but lower cost. And that forms your spectrum for storage to memory operations. And what we are looking at now is to bridge this gap, and many new memory solutions are finding their way. And each of this solution addresses certain market requirement and also fills this gap between performance and cost. We can talk about persistent memory. Micron solutions with 3D crosspoint are actually able to improve performance significantly and bridge the gap between performance and cost. We also provide high bandwidth memory solutions that can improve performance with increased bandwidth and reduced power. Computational storage is another idea to do more processing right inside the SSD, the solid state drives, with the controller doing the compute function. And as we move towards the right, we start talking about memory-centric computing and processing in memory or in-memory processing. The processing in memory is a further improvement where all simple logical functions and some of the processing can be done inside the memory chip itself. This saves power, and it also reduces the amount of latency that's involved in transferring data back and forth between the memory and the processor. So by taking advantage of the high internal bandwidth available in the memory chip, we can reduce power, provide faster processing time in the overall ecosystem. And the final one is more on neuromorphic computing, where different workloads need different architectures. And this is driving each one of many of the social media companies or search companies to be looking at their own customized solutions for the different workloads. So when we look at the spectrum of power, performance, and cost, there's an explosion in the requirements, and each requirement is unique based on the industry in which we are working, whether it is for data centers and cloud, or it is for mobile, or it is for autonomous vehicle enablement. All these different markets expect unique requirements from memory solutions to meet their own customer needs. And I'm proud to say that the semiconductor memory industry has been able to continue to advance the technology and develop new solutions to meet the customer requirements. Now, in order to meet all these requirements and keep progressing the technology, we face challenges at the silicon technology level as well. At the bottom of this slide, I've shown 3 different memory types. All 3 are in Micron's portfolio from DRAM, NAND, and 3D crosspoint. We are facing a lot of process challenges and equipment technology challenges as we continue to scale and shrink the lithography geometry. We have to enable high aspect ratio etch and gap fill. We have to improve the parasitics, the resistance and the capacitance in order to make the devices operate at a faster speed and lower power. We have to reduce contact resistance. And these issues scale from DRAM to NAND as well. But as the industry has transformed from planar NAND to three-dimensional NAND in the last 5 years, some of the challenges from length scale have changed with respect to planar to 3D transition. And 3D crosspoint is a unique materials challenge. We are using unique materials and new materials. They are very sensitive to the ambient, and we have to control the ambient around these materials. We have to enable damage-free etch solutions. So as you can see, as the product device performance continue to increase or become more stringent, to reduce cost, we have to continue to scale these technologies, and that requires new materials innovation, new equipment innovation, and that's going to continue to be a challenge where we have to provide lower cost, but also higher performance requirements. And like I said, this is still, semiconductor industry is still driven a lot by materials challenges. And today, anyone with material science degree, this is an area of excellent opportunity to come and work. It's a dream come true. We can take the periodic table and we are touching many of the elements within the table to work and bring it into production to enable these advanced semiconductor memory solutions and new solutions that are enabled by semiconductor memory products. We are seeing a significant growth in the memory industry. As I've shown here, the volume of DRAM memory solutions that were produced in 2019, which our industry measures in bits, was 12 times or greater than 12 times than what was produced a decade ago in 2009. And for the NAND storage solutions, the growth has been actually much higher, and it's 48 times more in this last decade. These increases actually also places a bigger responsibility on the semiconductor manufacturing companies. We have to understand that sustainability is very important to our operations. It's important to consider the incredible growth in demand our industry has experienced. And in meeting this demand, we also have to increase our innovations and new solutions that can enable to meet this demand in a sustainable manner. And I'm proud to say Micron's focused in meeting this challenge. While we deliver product solutions that are meeting our customer expectations and transforming their lives, we are also taking this responsibility around sustainability seriously. And we are focused in 4 areas in driving emissions, energy, water, and waste lower within our operations to meet the environmental sustainability goals. And we are applying our own innovative culture in coming up with technology solutions to continue to drive reductions in these 4 areas so that we can make our planet green and enable a much better future for the next generations. So I hope I've shared the story around why memory is important and how the memory solutions are actually making a big difference in the generation of data around us and how this data is being stored and moved, and how memory solutions are also enabling processing of this data, thus the advent of artificial intelligence and machine learning, so that we can all gain higher level of intelligence from the data we are generating. And using this intelligence, we want to make sure we can transform the way data is being used to make human life better. Memory is inspiring new experiences. Memory is accelerating the speed of data insights. It's driving more intelligence, and it is sparking new discoveries. And through all of this, memory is influencing our way of life and changing our world. I want to thank all of you for your attention and also for this opportunity to share some of my thoughts with the audience in India. We are facing a challenging time, but I'm confident that with the technology solutions and, and the vast human intelligence that we have amongst us, we will find a solution for this pandemic, and we'll come out of this strong, and we will come out of this to be better as a human race. All of you stay safe, and thank you.
Okay. Uh, Thank you. This was a pretty good talk from Dr. Naga. I now have Anand Ramamurthy, who is the Managing Director of Micron India, here with us to answer any questions that we have from the audience. I do see a couple of them, so I'll start with the first one that I see. Uh, it's asked, what is the next paradigm of storage? When do you think the biological storage will come?
Thank you, Naveen. Thank you, everyone. Yeah, it's an interesting question. I think thinking of memory in terms of at a DNA level is something that we've been talking about for some time now. So I think there are a lot of, it's an interesting thought because it kind of helps you innovate faster in the more non-biological real world. So I've seen some very interesting case studies and stories written about uh, memory as it relates to human cell and biology, but I still believe it's a long way out. But it's an inspiring charter that will ensure that we continue to kind of push the barriers.
Right. And then the next question which comes in, which is a combination of, actually it's a little bigger question. There is two parts of it. One is, when are we going to see the in-memory computing in mainstream? And secondly is that there's so much talk about the AI ML application in the many part of the silicon. Is memory going to utilize some of that for its functionality?
No, I'll answer both of them. So the first question is first. In-memory computing, already some of it is happening, right? We already have some level of compute sitting in and around memory. We do it in a basic SSD type applications today, so it's already happening. I think what we're looking for is essentially more compute power, so that you sit as close as possible to the source of memory, leading to efficient computation and translation. So I think we are pretty much there in terms of we're already doing it in principle. Question is to do it in scale and to do it across the board. And AI, ML, data science, we are using all of that in different parts. If you think of a company like Micron, that is, we're using a significant amount of AI, ML in our smart manufacturing floor. So as a standalone AI, ML application, obviously it's being used. We also believe that memory is a place where a lot of the acceleration can happen over time, not just the processor. So I think this will all be, this will be all existing nicely in a very systematic way, whereby we will have AI engines on memory, we'll have AI engines working on processors, we have accelerators. So I think we are clearly making significant progress towards that goal. And as the enterprise memory and storage applications and requirements are growing, it's a matter of time. I see we're probably in that decade where we see a lot of that happening.
Understood. Thank you so much, Anand, for joining us here to be able to answer on behalf of Dr. Naga. I know this is not a good time for him to join from the North America, but it was pretty clear thoughts from him, and thanks to you. On behalf of the ISA team, I would like to thank Dr. Naga for his time and video sharing his thoughts.
Thank you.
And thanks to you, Anand, as well.
Thank you. Bye-bye.